Among the important things is the protection logic diagram, how to read it or be fully aware of it. The protection logic diagram here, how you read it or understand it. The idea is quite simply that you have here a single line diagram, and this single line diagram consists of a bus bar. And here you have it coming down like this. Here is the withdrawable circuit breaker, and here is your isolator switch. And of course, between them is the dotted line and the triangle I told you about, which is related to the mechanical interlocking. What does this protection logic diagram do? It draws the bus bar for you, writes its data on it, as you can see, and places all the current transformers and the voltage transformer and writes the data. For each current transformer and voltage transformer you have, in addition to, of course, things like CVI. All right, very nice. And it tries to create a network or grid. What happens, for example? It tells you what this current transformer is used for, saying it went to the capacitor protection panel. And where did this one go? It went to the capacitor protection panel, okay? And where did this one go? It tells you, for example, this current transformer went to supply the power watt meter, all right? And where did this one go? It went, for example, to the busbar protection panel. He knows you, but the world is going on as it is. Taboo volt transformer told you that this volt transformer is going here too, to the power watt meter. It and the Korn transformer L2 are going here. Who has the ZIVI relay that we saw in the lighthouse building, which is the P control and protection unit? Control and protection unit. And it illustrates here all the binary inputs available on the P control and protection unit. It tells you, for example, that this binary input is spare, this one is spare, and this one is spare. For instance, let me show you here. This is the first binary input, which indicates the breaker is on. The second is spare, and the next one means trip circuit, supervision fail. I'm not sure, but this means breaker off, this means breaker in test, and this means breaker in service. It illustrates it for you to understand how the whole drawing works. All right, that's good. Then it starts to tell you about the interface between this relay and other things. What do other things mean? The grid drawn for you here is labeled above as 13.8.10 circuit breaker closed, here circuit breaker. 168010 circuit breaker closed, here circuit breaker close block, circuit breaker, trip coil 1, trip coil 2, local indication, SAS, and so on, a set of things. So what do you understand from this? Let's see together. Now, let's say I want to give a close command. Can't you give a close command from local or a SAS? All right, you give a close command and you'll find an arrow coming out from the relay and placing a point here with the first column, which is circuit breaker closed. It means it can give a close command to the circuit breaker, all right? And from it, you also come here, move up this column, which is trip coil 1. This means the controlling unit sends a command to open the breaker, but to whom? To trip coil 1. And trip coil 2, no, it doesn't. So the open command is only on trip coil 1, as long as it is open as protection on 2 trip coils, but open on trip coil 1 only. Okay, for example, he comes and tells you, for example, you have something like 27 DC, meaning 27 DC, which is DC supervision. Okay, DC supervision, so the engineers of its NCQ are one of the two, meaning its NCQ supervision is one of the two, 74 DC, which means supervision on DC. Yes, 74 DC means supervision on DC. Either 27 DC, 27 for people who understand protection, knows that this 27 means under voltage on DC, meaning the quality of DC is low, meaning what you are doing. You are saying the quality of DC is low, meaning there is a problem with DC. So it tells you what I found supervision. In the case of DC supervision, what happens? You will find it running like a capsule and telling you remove the signal to the base and remove the signal, for example, to the BCU, the command BCU, which is the command alarm panel. Okay, alarm panel. All right. And so on. You start to see what the logic is, meaning what the logic diagram is that you have in your cell. Not in detail, but it tells you what it consists of. All right, nice. Okay, now let's come together and see how the protection topic works here. Now it tells you that you have a circuit breaker. Let's assume you have a single line diagram with circuit breaker 1, circuit breaker 2, circuit breaker 3, 4, 5, and here you have remarks. What are we going to talk about? All right, and the single line diagram that I'm following, Engineer Rashid, what is it? You have circuit breakers 1 and 2, which are in section 1, and you have circuit breakers 4 and 5 in section 2, and circuit breaker 3, which is who? Circuit breaker Tata, which for you is the bus section, Do you understand? So you have the first bus with 2 breakers on it, and the second bus with 2 breakers on it, and in between them, what is there? There is a bus section. Beautiful, very nice. So it tells you if there is a busbar differential trip, meaning the busbar protection has detected a problem on the busbar, what should it do? On the first busbar, it should disconnect all the breakers related to this busbar, which are certainly the ones on this bus, in addition to, okay? I said, okay. He said, well, suppose it happens on the second bus, then it should disconnect the others along with okay. And since this is a trip and it will disconnect these breakers, when it disconnects them, it should also activate the breaker function, which is the breaker failure, okay? Why? Because maybe these breakers won't open. For example, let's say this bus section doesn't open. So naturally it fails and the second bus bar continues to be fed through the first bus bar because the bus section between them is closed. So here, if this breaker doesn't open and the breaker failure function recognizes that this breaker isn't opening, what will it have to do? It will have to trip the breakers on the other bus. Why? Because the supply will continue to feed the fault, right or wrong? Exactly. Okay, and if I have something like, for example, a circuit breaker, and this is a transformer like the single line diagram that is present here. For example, all right, this is a case where circuit breaker one had an issue and didn't open. Okay, you will trip the bus bar, but at the same time, the supply might come from above, from the transformer. So here it is said that you must trip the remote end. You have a breaker failure and the breaker failure trips everything. Consider this with me. If a breaker failure occurs, it trips all the paths that could feed this fault through this breaker. Whether the breakers connected with it are on the same bus or the breakers connected from the other side, if it could be its own or it could be theirs. All right, very good. Transformer in a chamber, so what will be its upstream? Its upstream, all right, very nice. So any protection on circuit breaker 1 will trip only circuit breaker 1 and initiate a breaker failure in case it fails to open. Then circuit breaker 2 and circuit breaker 3, which are the breakers next to it on the same bus, will trip immediately, as well as my bus section. Okay, suppose he said, thank God and peace be upon you. Okay, he tells you, suppose circuit breaker 1 experiences a breaker failure and the first stage is activated. What will I do? I will retrip it, attempt the trip again. All right, suppose it doesn't open, reaching the second stage, which is stage 2. What should I do? Then I must trip CB2 and trip CB3, which is the other breaker, as well as the bus section. Similarly, of course, for CB2, right, the same applies. As for CB3, which is the bus section itself, the bus section itself will undergo a trip and breaker initiation. Now, if the breaker doesn't open in the first stage, I will attempt a retrip. If it doesn't open for the bus section between two buses, right or wrong, right, then you must disconnect both buses. So any issue on the bus section will disconnect. What? Both buses. All the breakers, CAN connected to this bus and all the breakers connected to the electronic bus, of course, will be affected by CB3 manual operation from CB1 and CB8.